Hello everyone. Today we are continuing with the series of lectures on IC engines. We have already covered two lectures, one on introduction to IC engine and the second on terminologies of IC engine. Today we will be talking of classification of IC engine. By the end of this module, learner will be able to identify and explain the various parameters used to classify IC engines, identify real-world examples of each engine type and explain why they are used in specific context. Evaluate the impact of engine classification on design and manufacturing considerations. Comprehend how classification affects engine performance and suitability for specific applications. In this presentation, we will be having the title slide, learning objectives, index, parameters used to classify the engines, classification according to applications, classification according to basic design, in which we will be covering the reciprocating compressors as well as rotary piston engine. In the rotary we also have the Wankel engine. Then we will be talking of classification according to operating cycle, covering Carnot, Otto, diesel and dual cycle. Classification according to working cycle, that is 2-stroke and 4-stroke engines. Let us start with the presentation. So classification of IC engines can be carried out on the basis of all these 12 parameters, namely application, basic engine design, operating cycle, working cycle, valve port design and location, fuel, mixture preparation, ignition system, stratification of charge, combustion chamber design, method of load control and cooling. So let us start with the applications. As we have seen in the day-to-day life, we are very much encountering the cars, trucks, buses. So automotive is one of the application. Then we have locomotives. In trains we have DMUs which run on diesel engines. Light aircraft engines, they are also working on this automotive applications. Then marine, in the marine we have outboard, inboard and ship type. Outboard means the engine is placed outside the stern, whereas inboard means engine is placed inside the hull of the boat. Then we have ship engine. Power generation, we have portable domestic genset, fixed peak power gensets. In agriculture we use tractors, pump sets. In earth moving devices we have dumpers, tippers, mining equipment. For home use we use lawn mowers based on engines, snow blowers and other tools. Now we will be classifying the engine on the basis of basic engine design. So we have the reciprocating engines. In this we have single cylinder and multi-cylinder engines. Then we have the rotary engines. In this we have the single rotor Wankel engine and multi-rotor Wankel engine. Then we also have the turbine based rotary engine. So within the reciprocating engines, multi-cylinder may also be classified on the basis of arrangement of the cylinder. We have inline arrangement of cylinders, we have V-type arrangement, radial arrangement, opposed cylinder and opposed piston arrangements. For example, Ford EcoSport has 3-cylinder engine which are placed in line. V6 cars include Hyundai Sonata Gold, old Honda Accord V6, Skoda Superb V6 and Toyota Camry V6. V8 cars include the luxury cars, namely Audi RS7, Ford Mustang, Audi Q7, Volvo S80, BMW 750 Li. Here is the working of reciprocating engine. You can see the piston arrangement. Piston is connected to the connected rod and then to the crank, and then crankshaft is rotating. So here 4 piston, they are placed here in inline arrangement. Then the second we have the V engine. The shape of the engine arrangement is in V shaped. So one cylinder, we have 3 rows, 3 V rows. So total 6 cylinders are there. In the radial engines, the cylinders are located in radial direction from the center of this circle. And the pistons, they are shown here, but the cylinders are not shown. However, you can imagine the cylinders by seeing the pictures of the valves, inlet and exhaust valves here. Then we have an opposed cylinder engine where one cylinder is opposite to the other cylinder, and the links are so made that they rotate the crankshaft turn by turn. Then the final one is the opposed piston system. Now you can see these 2 slots are there through which the inlet charge is entering and exhaust charge is leaving, and 2 pistons are there. They are placed opposite to each other. When the charge enters here, it is being compressed by both the piston and then burnt, and then exhaust gases leaves from here. You can see the inlet charge as blue lines and outlet charge as red lines. These are some arrangements, same arrangements: inline arrangement, horizontally opposed piston, radial engine and V-shaped engine. These are the engine blocks which are made so that the piston is placed inside these blocks with the help of engine liner. Here inline engine is there, V-type is there, slant is there, W-type is there, and opposed piston arrangement is there. You can also see in this animation the working of opposed piston cylinder arrangement. Here the W-shaped engine is shown, and when we consider the angle of V to be 180 degrees, it becomes opposed cylinder arrangement. Now there is a difference between radial and rotary piston reciprocating engines. I have already told you the radial engine, in which cylinders are placed radially along this circle and the piston moves inside it. Now you can see here the cylinders are fixed, they are not rotating, whereas in rotary engine the cylinders are rotating and the piston remains at the same place. Now the rotation of the cylinder causes this piston to come inside and go outside. So this engine is also called gnome engine. G is usually silent, we call it gnome engine. So crankshaft stationary and cylinder block, they rotate. Now rotary Wankel engine. Now rotary Wankel engine is an engine with a rotary piston. Instead of reciprocating piston, we use here rotary piston. Mazda Japan has the expertise in this, and it is the only company which has perfected the art of making this rotary Wankel engine. We have Hercules motorcycle here, Mazda car is there, Mazda powered Scorpion helicopter is there, and a combustion snowmobile is there. Now video, you have a mid housing plate is there, in which the cooling jackets are there. Cooling jackets is for removing the heat from the cylinder. Here the intake port is here, and the rotor housing are provided along with this mid housing. On the rotor housing you have exhaust port and the spark plug inserts. Here you have again the coolant jacket so as to remove the heat from the engine. An eccentric shaft is inserted here, and on this eccentric shaft we have rotor journals. Now on this rotor journals are fixed the rotors. This is the rotor, triangular shaped rotor is there. It is having a combustion cavity at all the three faces of this triangle with an apex seal sealing the gases from moving from one sector to the other. Then outside we have the housing plates, and cooling jacket is there to provide the cooling of the engine. Now stationary gear is provided. This stationary gear, it mesh with the internal gear of the rotor gear, and this is how the rotary engine works. Now you can have a look at this rotor. So you can see as the intake fuel is coming, this piston is rotated and it is compressing the gas in between it. So inlet charge is being compressed, and here the spark plugs are there. So ignition will be caused, and this ignition will cause expansion stroke, and hence you get the power from here. Then finally the exhaust is moving out. So this is the working of this engine. Now you can see the construction here also. Anatomy is there. You can see a fixed gear which we have seen earlier. Black one is the fixed gear. The red one is the internal gear, which is on which the piston is fixed. And as it rotates, you can see it is eccentric. Piston is eccentric about this center. So as it rotates, the inlet charge is coming from this side, shown in blue dots. So here the suction is there, compression is there, here the spark plug is there, so ignition will take place, expansion will take place, and from here the exhaust gases move out. This is the operation of the rotary engine. Now advantages of this rotary Wankel engine. Now you can see we are having minimum moving parts. We are not having any camshaft, right? We are not having any say connecting rod. We are having the piston which is rotating. Hence aircraft manufacturers prefer rotary engine to piston engines. So this is the maker. Skycar is there. Skycar is a company that uses this rotary Wankel engine in their helicopter. Since the rotors spin at 1/3 the speed of the output shaft, the main moving parts of the engine move slower than the parts in the engine, right? So hence this helps with the reliability. Now balancing is also there, because all the parts, rotating parts, they are rotating in one direction only. So hence they are internally balanced. But the power delivery is very smooth, because each combustion event lasts through 90 degrees of the rotation of the rotor's rotation. So you can see in every phase you are getting a power stroke. So it delivers powers for 3/4 of each revolution. Whereas in reciprocating engine, it delivers only in 1/4. That is the power stroke. So but the problem here is, challenges which we face while making this rotary engine is that it is very difficult to make this rotary engine. And because this requires the proper sealing here, it should be, inlet charge should be properly sealed from the burnt charge. So hence the US emission regulation, they become difficult to avail. So high manufacturing cost, mostly because of the number of these engines produced, is not as high as the number of piston engines. Why? Because you are not having mass manufacturing of this engine. So then high fuel consumption is there, because in every revolution you get 3 power strokes. So thermodynamic efficiency is reduced. Then next is classification of engine according to operating cycle. So you might have studied Carnot cycle in the thermodynamics. So in this, what is there? We are having 2 isoentropic processes and 2 isothermal processes. 1 to 2 is heat addition, isothermal heat addition. 2 to 3 is isoentropic expansion. 3 to 4 is isothermal heat rejection. 4 to 1 is isoentropic compression. The same diagram is drawn in PV cycle also. You can see 1 to 2 heat addition, isothermal heat addition, 2 to 3 isentropic expansion, 3 to 4 isothermal heat rejection, 4 to 1 isentropic compression. So this is the Carnot cycle. Then the next cycle is the Otto cycle. In Otto cycle, what is there? The pressure and volume diagram is drawn here. You can see the intake stroke. This is the ideal cycle. All these cycles are for ideal cycles. Now in ideal cycle, we consider air as the standard working substance. So from here, the intake stroke is taking place at constant pressure. The air is brought inside. It is compressed adiabatically or isentropically. Then the heat is added here at constant volume. You can see V2 is equal to V3. Then after that, adiabatic expansion takes place, and finally the heat rejection takes place at constant volume. So this is the PV diagram. The same is drawn here. Since 1 to 2 is isentropic or adiabatic, so S1 and S2 remains same. 2 to 3 is heat addition at constant volume, so it is a hyperbolic curve rising upward. Then 3 to 4 is adiabatic expansion, and 4 to 1 is heat rejection at constant volume. Now this was the Otto cycle. Now this cycle is basically used for petrol engine. It is the ideal cycle for petrol engine and act as guideline to the working of this engine. Then we have the diesel cycle. In the diesel cycle, we have the cycle remains same, only difference is of heat addition. Heat addition takes place at constant pressure instead of taking place at constant volume. Now you can see here 1 to 2 is the isentropic compression. 2 to 3 is isobaric heat addition. Rather than isothermal, it becomes isobaric. So 3 to 4 is isentropic expansion, and 4 to 1 is isochoric. At constant volume, heat is rejected. Next we'll be talking of dual cycle. In the dual cycle, what is there? This is the practical cycle. Means though it is ideal cycle, it is used as guideline for the practical cycle. Here the intake stroke takes place at constant pressure. Then we have adiabatic compression 1 to 2. 2 to 3 is again isochoric heat addition. 3 to 4 is isobaric heat addition. So here the dual processes takes place for the heat addition. One is the isochoric and the other is the isobaric. And after isobaric heat addition, the power stroke or adiabatic expansion takes place, and then finally the heat is rejected by the engine and you have the final stroke as exhaust stroke. So the same PV diagram, the same processes, they are shown in TS diagram here. Next we talk of the working cycle. So classification according to working cycle, we have 4-stroke engine and 2-stroke. In 4-stroke engine, the complete mechanical cycle takes place in 4 strokes, namely suction, compression, power and exhaust. These engines can also be naturally aspirated or supercharged. Naturally aspirated means you are not increasing the pressure at the inlet. In supercharge, we increase the intake pressure by the use of compressor driven by the engine crankshaft. Then we have also the turbocharged engines. In turbocharged engines, the pressure is increased by the use of turbine which run by the exhaust gases. Then we have the 2-stroke cycle comprising of suction and compression and power and exhaust strokes. So this may be naturally aspirated or turbocharged. You can see the working of the 4-stroke engine here. Here you can see the charge is coming, blue dots are showing that the inlet charge is coming inside. Suction is taking place, followed by compression, and the spark is generated by this spark plug. You have the ignition and the power stroke, and after that the final is the exhaust stroke. You can see the opening of the valves here. Here the mechanisms are also shown. You can see the crankshaft. On the crankshaft is placed the crank gear and the crank. This crank gear is connected to this cam gear. The cam gear, you can see, is double the size of this crank gear. Only in 2 strokes you want to open these valves, inlet and exhaust valves. So hence the cam rotates here. As the cam pushes this pusher rod, it moves this rocker mechanism and opens this valve. So this is the working of the complete mechanism of opening and closing of this exhaust valve. Both these valves remain in closed position with the help of the return spring. So you can also see the spark mechanism here. This spark is connected through this distributor, ignition coil, and this battery. This is the breaker circuit. So as the larger cam, which I am showing with the pointing with this arrow, so this larger cam, it pushes this circuit breaker downwards and cut this circuit, and during that cutting of the circuit, what is there? The battery, it gives the charge to the spark plug, high voltage to the spark plug, which causes a spark, and then burning takes place. So this is the 4-stroke engine. Now let us talk of this 2-stroke engine. In 2-stroke engine, the suction and the compression takes place simultaneously. How it takes place? The suction is coming inside this crankcase. Now here is the reed valve. Through this reed valve, the charge comes inside. It is pushed to the cylinder through this transfer port and is compressed. So when the piston comes down, the expansion takes place, whereas when the piston moves up, the compression takes place. Now you can see, when the compression takes place, the charge comes into the crankcase. So compression as well as suction, they take place simultaneously. And when the expansion takes place, this charge, black dots, you can see moving out of this exhaust port. So here we are having exhaust port, transfer port, but this valve is there, which is called the reed valve. So all this inside this engine, the suction is taking place in the crankshaft only, crankcase only. Next we talk of the comparison of this 4-stroke and 2-stroke engines. 2-stroke completes it completes in 2 strokes, that is in every revolution. It uses ports, no valves are there, simple design, compact and light is there. Whereas 4-stroke engine, it completes in 4 strokes, and every other revolution it gives you the power stroke. So it uses valves and camshaft complex mechanism is there, and it is bulky. Why it is bulky? Because since it is delivering only 1 power stroke in 1 revolution, in 2 revolutions, so hence it needs a larger flywheel for its movement. Then performance and efficiency, power output. 2-stroke give you higher power to weight output, whereas 4-stroke give you lower power to weight output. So fuel efficiency is more in case of 4-stroke engines, whereas it is less in case of 2-stroke engine. This is because due to scavenging. Scavenging is, say, sweeping out the exhaust gases by the inlet charge. Volumetric efficiency is less due to lesser time of induction in case of 2-stroke engine, whereas it is more due to more time of induction in 4-stroke. Torque is maximum, it is more regular in case of 2-stroke engine. So hence lighter flywheel is used, whereas lesser regular torque is there in case of 4-stroke engine, making the flywheel to be heavy. Lubrication of this 2-stroke engine takes place by mixing the lubricating oil with the fuel. So hence we can't use heavy lubrication oil here because it may damage the engine. Whereas in case of 4-stroke engine, we have a separate lubrication system, so hence heavier oil can be used. So maintenance, it is easier to repair. 2-stroke engine is easier to repair, more frequent rebuild, more wear and tear. But 4-stroke engine, it has longer life, less wear and tear. Emissions, for 2-stroke engine, it is higher emissions since unburnt fuel also moves out with the exhaust gases, whereas in 4-stroke engine we have cleaner combustion. Cost is cheaper to build and maintain. 4-stroke is more expensive due to complexity. Cooling and lubrication requirements, since one power stroke is produced every revolution, so 2-stroke engine requires higher cooling requirements. Similarly, 4-stroke engine, you are having in 2 revolution only 1 power stroke, so low requirements for cooling are there. Application of these engines, 2-stroke engines, they are used in smaller engines like chainsaws, scooters, small boats, dirt bikes, whereas 4-stroke engines, they are used in cars, motorcycle, generators and industrial machinery. So that's all for the classification today. We will be continuing with this classification in the next lecture also. Thank you.